In this video we will focus on three aspects of biomass conversion to bioenergy. First of all, we will take a look at the different forms of biomass that can be used for bioenergy production. Next, we will take a closer look at the different techniques for biomass conversion. To produce bioenergy, we can use different forms of biomass. The most commonly used are forestry crops and residues and agricultural crops and residues. Less well known are sewage sludge, industrial residues, animal manure and domestic solid waste. The different types of biomass have different characteristics such as moisture content, particle size and composition. Composition refers to the amount of cellulose, hemicellulose and lignin. Depending on the ratio of these compounds, biomass is more or less readily biologically degradable. Sewage sludge and animal residues are very wet biomass sources which contain a lot of water. As a result, they typically have a low energy density. To produce energy from these wet streams, usually some kind of pre-processing is needed, such as active or passive drying. Forestry crops and residues and agricultural crops and residues are less wet, but often need their size reduced for efficient energy production. This can be done by cutting, chipping, shredding or pelletizing. The moisture content and size of municipal waste and industrial residues shows large variation. The need for pre-processing needs to be decided on a case-to-case basis. When we look at the different techniques to convert biomass into bioenergy, we can distinguish four different conversion processes: mechanical, chemical, biochemical and thermochemical conversion. For each of these processes we will discuss the techniques and the input, output, efficiency and practical availability of these techniques. The most common technique for mechanical conversion of biomass into bioenergy is called crushing. Crushing can be used to extract oil from oil-rich crops such as rape and sunflowers. The extracted oil can be converted into biodiesel or biofuel through a series of chemical conversion steps. The production of biodiesel and biofuel out of oil-rich crops is a proven and simple technique that is applied worldwide. The efficiency of crushing depends on oil content of the biomass. With chemical conversion, biomass like wood or straw is separated into various monomers and polymers, using hydrolysis and extraction. These monomers and polymers can be used as raw materials for food and chemical industries, but also for the production of bioethanol using fermentation. Week 4, which focuses on biopolymers and biocomposites, will go more into detail about monomers and polymers. The production of bioethanol, like the production of biodiesel, is a proven technique that is used in many countries to produce biofuels. For example, the policy in Brazil is to produce 25% of the transport fuel from sugarcane. The third process to convert biomass into bioenergy is biochemical conversion. Biochemical conversion is also called fermentation. Fermentation is an anaerobic microbiological conversion process that produces either biomethane or classical bioethanol. In the first stage of microbial conversion, organic complex molecules are broken down into simple sugars, amino acids and fatty acids. This stage is known as the hydrolysis stage. In the next stage, the acidification stage, acidogenic bacteria breaks the hydrolysis stage products into simpler molecules and volatile fatty acids. These simpler molecules and volatile fatty acids can be transformed to biomethane by methanogens. This is done in the methanogenesis stage. If methanogenesis is inhibited, acidogenic bacteria will transform the simpler molecules and volatile fatty acids to bioethanol. Fermentation is applicable for wet biomass. It is a proven technology that is used worldwide. The efficiency of fermentation based on organic dry matter can be up to 90%. The last biomass conversion technology is thermochemical conversion. We can distinguish four main techniques: combustion, torrefaction, pyrolysis and gasification. Combustion is also called burning. This means adding oxygen to the free chemical energy content from biomass. Combustion produces heat. Driving a car is a good example. A rather new thermochemical process is torrefaction. Torrefaction is carried out under atmospheric pressure and in the absence of oxygen, at temperatures ranging between 200 and 300 degrees Celsius. Torrefaction mainly leads to char and gases. Liquids are not formed. Pyrolysis is a technique that is similar to torrefaction but at a higher temperature. The products are char, oil and gases. We can distinguish slow and fast pyrolysis. The main differences are the process temperature and the ratio of the products formed. The fourth chemical conversion technique is gasification. Gasification is a process that converts organic materials into carbon monoxide, hydrogen and carbon dioxide. This is achieved at high temperatures with a controlled amount of oxygen, so no combustion occurs. The resulting gas mixture is called syngas, and this in itself is a fuel. The next table shows the input efficiency and the practical availability of the different thermochemical conversion techniques. As you can see, most of the techniques are applicable for all types of biomass except sewage sludge and very wet biomass. Gasification can be used for all types of biomass. Both combustion and gasification are proven and common use techniques. The other techniques are in a pilot scale phase. As you can see, the highest efficiency can be reached with slow pyrolysis and torrefaction. Combustion and gasification both have the lowest efficiencies.